this variability that only you would think a human artist, a human designer, would be able to put into it. We normally imagine nature as always producing repetitive structures that are relatively mechanical, like ice crystals. But snowflakes, because they are produced within a turbulent field up in the not in your refrigerator's freezer, but up in the air when there's turbulent vortices and so on. The vortices themselves cause every snowflake to undergo different conditions and therefore to grow in slightly different ways. The history of production of each snowflake is unique and singular. And even though the ice crystals are also unique and singular, that singularity is not expressed. A singularity is tamed, and we tend to look at them as a repetition of the same. Snowflakes show us what repetition of differences are. So, these critical points of intensity are important. What the hell, I just ran out of time. And I'm going to have to move really, really fast to the next thing. Because, can you guys give me 10 extra minutes? Okay. Because again, Deleuze is the philosopher of difference. He's always attracted to whatever parts of nature show the most differences. Intensive thinking then uses differences in many different ways. It uses them in the sense that differences drive processes, and therefore until the differences are cancelled, everything is dynamic. But even in the product of those intensive differences, there are entities that display their singularity and express their singularity in a more artistic way, in a more open-ended way, with a more open-ended aesthetic than other entities. And Deleuze wants us to make maps of those distributions of differences. Map those aspects of the earth where the earth expresses differences more vibrantly, more idiosyncratically, and map those other parts of the earth in which differences are expressed less singularly. Because as an artist, you're always going to get more inspiration from those parts of the earth in which difference is more expressive than those parts of the earth where differences are not expressive. You can listen to a bird that chirps and just chirps the same way all over, beep, 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 beep. Or you can listen to a blackbird or a nightingale in which the song is continuously different. Whenever I'm walking through the park and I hear a blackbird or a nightingale, I stop to try to wait until in my mind, that loop of the song has to repeat itself, because it's just some kind of tape in the bird's brain. Well, that's not the case. Nightingales and blackbirds, Deleuze writes an entire chapter about bird songs in 1,000 Plateaus. They never repeat themselves. Those birds are actually artists. And at least one classical musician from the 20th century, Oliver Messiaen, dedicated an entire classical piece, a modernist classical piece, but a classical piece to the nightingale and the blackbird, honoring them as the first artists on the planet, the first animals that were actually capturing the repetition of differences, and I misspelled differences again, that's something about me today, of snowflakes. Deleuze wants us to get our inspiration from finding those places in nature where differences are expressed at the most. So finally, topological thinking. I'm going to go fast through this because I'm going to return to this. This is the type of thinking that he uses to think about that immanent, impersonal God that we were talking at the beginning of the class. This is not going to make sense, particularly using the word God, until the very last class, until Wednesday night. But believe me, I'm going to return to this because otherwise I'm going to end up looking like some kind of New Age hippie to you, and I would rather kill myself than do that. I'm going to introduce it right now, but you will see how it actually makes sense in terms of spirituality and in terms of finding what underlies this expressivity of nature in that class. Right now I just want to introduce the basic concept because this has been very influential to Deleuze. Here, just like we needed to distinguish two different types of properties, intensive and extensive, here we need to introduce the difference between metric and non-metric spaces. And the difference is that Deleuze is going to need this concept to think about this space, the actual space of nature and actual beings, and he's going to need these spaces to think about that other space, the spiritual space of Spinoza. It's a space that cannot possibly look or resemble this space at all. It needs to be another spatial dimension that is every bit as real as this one, but it is not directly perceptible because it's non-metric. Let me explain really fast. When you were, and let's utilize a very simple space, a folded two-dimensional space, because that's easy to draw and because that's easy to understand. If you were at the beginning of the 19th century and wanted to study what that space is mathematically, you would inscribe that space into a set of Cartesian coordinates that you use as reference, and at every point in that space, you measure the distance that it has relative to those coordinates. You know, this is x, this is y, this is z. And you would give that point equals x, y, and z. The numbers that you would get from its distance to the coordinates, right? So every point in that space was an x, y, and z triad of numbers. And this is the way people thought about those spaces at the beginning of the 19th century. Then came two guys which revolutionized everything, Gauss and Riemann, who created the first non-metric spaces in history. Gauss said, why do we need those Cartesian coordinates? We don't need it. We can explore space exclusively with local resources. And he reasoned this way. Well, you know, Leibniz and Newton, a century before us, created what's called the differential calculus. Now I understand that talking about the calculus, particularly the way calculus is taught in high school, such a horrible way, brings everybody, oh no, the calculus. But think about the first word, the differential calculus. There's the word difference in it, right there. And of course, Deleuze, attracted as he is to everything that has the word difference in it, immediately zeroing the differential calculus. The differential calculus is all about rates of change. That is, speeds of becoming. It's all about change, not about sameness, not about static things, but about change. And it's about how slow or how rapidly change happens. It's about rapidities and slownesses. So the differential calculus, I'm not going to go into the details of it, but you can imagine that one of the operators of the differential calculus, what it does is you feed it on one hand a rate of change, and it outputs on the other side an instantaneous rate of change. What would that be useful for? Imagine that you have a corpse, that you're a forensic doctor, you have a corpse in front of you with a bullet hole in his forehead. Oh, poor bastard, you know, he died. But fortunately he died fast, you know, you can tell the bullet hole and the expression in his face. And you want to know at what speed the bullet was going, not on average, because that you can tell from the manual for the gun, you know, the bullet travels at 200 miles per second on average. Now you want to know at what speed it was going exactly before it hit the guy on the head. That is, at that instant, right before the wound began to become a wound. Well, that's what the calculus gives you. The instantaneous value right before the bullet went into the head. So Gauss thought,